That is very helpful to me. All right. Now we're going to talk about adding polynomials. Mostly what we're reviewing right now is adding like terms, remember? So like terms, didn't we talk about like terms last week? Did we talk about like terms last week? Yeah. So same variable, same coefficient? Nope. Same variable, same exponent, right? And so that's what we're going to do. So remind ourselves what like terms are. These are notes that are for you. If you don't want to write everything I'm writing, you don't have to, but what else you got to do? I'm an abbreviator for the same variable with the same exponent. My handwriting is a lot more legible if you're listening while I say it. And then basically, so this is a trinomial plus a trinomial. But in this case, these parentheses are not necessary, right? We're adding and subtracting everything. If we can move anything around that we want, we can add and subtract in any order, as long as we keep the signs the same, right? Remember, subtracting is the same as adding the opposite. So as long as we keep that in mind, we don't need these parentheses. We do need the marker. I think when we have a bunch of terms, I like to mark my like terms, just a little symbol underneath to remind me what I need to be combining. That's another one of those. And I've got two constants, right? So I look for the same one. We are going to always write our, well, we're not always going to write it in standard form, but it is good form to write the polynomial in standard form. When we're working with partial products, though, sometimes we don't see that. Probably you'll see that it's not written in standard form, especially when there's two variables. If you're multiplying the two variables in it. Okay. So I've marked my like terms, the greatest degree is 3, so that one's going to go first. And when I have multiple ones, I like to mark them out. Try to save myself a careless mistake. I am really good or bad at thinking in perspective, a careless mistake. X's are next. And constants are last. When I mark everything out, I know that I included all the terms in my answer. You with me, Ethan? Nice. Mistake. Where did I get it? It's plus x squared. Positive 5 minus 4. Good catch. Plus x squared. That's the kind of thing. But I will tell you, I am the girl that will sit there and check that kind of stuff if I'm taking a test or something. So you guys see those kids too, right? This is the careless stuff that's the kind of mistake I make, and that's the kind of mistake I look for when I'm checking my work on a test or something. Which is what I should be doing when I'm getting in front of 20 kids doing it as well, right? But it happens. Alright, this is not a video. I use a snipping tool to make these notes, so that was the easiest way to do it. Alright, now this parentheses do matter, right? They're trinomial minus a trinomial. So the big issue here is we have to make sure that we distribute this minus or negative, however you think of it, to every term in that second trinomial. So the common mistake is to subtract some of it, but not all of it, right? So make sure you're distributing the negative throughout that second trinomial. And I'm just writing distribute the negative throughout. So it's going to be minus x squared minus 5x minus negative 9. And just to illustrate, I am going to actually, who am I kidding? If I were doing this on a test, I would rewrite this step just to make sure that I have not messed up my sign. So minus x squared minus 5x plus 9. So minus negative 9 plus 9. Combine my like terms. 3 minus 1, see if this one can get this right this time. 2x squared minus 7x and plus 9. Say again. Oh, I forgot my one. Plus 1 there. Let's say that. Perfect. Thank you. Yep, I forgot it there. All right. Multiplying. We're just using the distributive property. Let me see. Everything? Oh, my Lord. Where? Oh, there's everything. See, I told you I was going to try to expedite this, so I'm getting into a hurry. Also, not a good thing for me. All right. I'm regrouping. Start with the beginning. 3x cubed minus 2x plus 1 minus x squared minus 5x plus 9. All right. See if I did it now. Yes. Oh, you know what I did? I subtracted the cube and the square before. That's what I did. 3x cubed minus x squared minus 7x and plus 10. All right, Grant and Jewel, my proofreaders. Do I have it right this time? All right, sweet. All right, I'm slowing down. We are distributing monomial times a polynomial. Keep track of your signs. Don't forget distributing to any of the terms. 1, 2, 3, 4 terms that we're distributing to. So, you with me, Henry? Did you already do this one? What'd you get? Did you do this one already? No. All right, we're working on this one. You can work ahead of me if you want. You can catch my mistake again. All right, so it's coefficient times coefficient, like base times like base, and we can add the exponents on them. So 5 times 3, 15, x squared times x to the 5th, x to the 7th. This is minus 5x squared times x cubed, so minus 5, add the 2 and the 3, x to the 5th. 5x squared plus 7x, so that's plus 35x cubed. Coefficient times coefficient, variable times variable, and then minus, oh, that 3 looks like a big 3 instead of an exponent. Minus 20x squared. How did you, Grant? No silly mistakes. Great. What you got, Jewel? Nice. All right. You think I messed that one up? Now this one, we distribute, so when we multiply, the easiest way for me to multiply this is just to rewrite it as a sum of 3 different products. So what does that mean? That means I'm going to take the 2, multiply it by everything in this trinomial, the 2x squared rather. 2x squared times x squared minus 5x plus 7. And then I'm going to take that negative 3x and multiply it by everything. And then parentheses. I got to go down a line. So 2x squared minus 3x plus 1 and x squared minus 5x plus 7 3 times. And then we're going to do exactly what we did in example 4, but we're going to do it 3 times. Lots of opportunities for me to mess it up. So let's go ahead and distribute. My handwriting is probably not helpful for me. x to the fourth minus 10x cubed plus 14x squared minus 3x cubed plus 16x squared minus 21x plus x squared minus 5x plus 7. All right. How do we feel about that step? All right. I get thumbs up from Grant. Anybody have a question? Is there another way to do that? Yeah. It is tedious, right? You got to use a strategy that works for you that helps you keep track of stuff. I mean, you could also just do it as 3 separate problems and then go through and add all together. That might be better for you. Now we're going to mark like terms. I only have 1, 2x to the 4th power. Remember, we're writing in standard form. The greatest degree here is 4. I got x cubed minus 13x cubed. I got x squared. 14 plus 15 plus 1, 29 plus 1 is 30, plus 30x squared. I got my x's, so minus 26x plus 7. Everybody get the same thing I got? Hudson, did you get what I got? All right. FOIL only works for binomial times a binomial, but it is a quick, easy check. You don't have to rewrite it like we rewrote this one. Remember, FOIL is first, outside, inside, last. The first, outside, inside, and last. And then we combine our like terms. Any questions? Right. So now we're going to be multiplying binomials where we get special products. Example 7 in particular, we're going to be multiplying these so we can kind of see where the shortcut or the formula that we can use for special products comes from, right? If we recognize the 2 binomials, we know by the look of them that they're going to have special products, so we can use that formula. We can use the shortcut. We don't have to multiply it long form, right? So before we do that, we're going to do it long form. So we're going to go through just because I'm around that room. X minus 5 times actually. I'm going to use FOIL so I can save some space. So first term multiplies x squared outside plus 5x, inside minus 5x, and outside minus 25. These are opposites. You combine opposites, you get 0, right? So our final product is x squared minus 25, a perfect square minus a perfect square. We multiply 2 binomials that are identical, except one is addition and one is subtraction. That is a difference of squares, because the product is a perfect square minus a perfect square, the difference being the subtraction, right? So if you see a binomial that's a perfect square minus a perfect square, when we do factoring, we should remember, oh yeah, we can take that shortcut again to factor it. So difference of squares. Is a squared, let's do this. So it's going to look like this as factors. A plus b times a minus b, or a minus b times a plus b, and that's going to equal a squared minus b squared, and that's our shortcut or our formula. So number 1 is the difference of squares. Identical binomials except one they have opposite operations, right? One's subtraction, one's addition. Now the next two here, when you square a binomial, your product is going to be a perfect square trinomial. So what does that look like? So we're going to go ahead and square x plus 5 using our, remember that it looks like this, right? And we're going to use FOIL, x squared plus 5x plus, so first outside, inside, so we get another 5x, and last is 25. So this perfect square trinomial simplifies to x squared plus 10x plus 25. So the shortcut is, so first off, we recognize this is called a perfect square trinomial. The first term, because it's a product of a squared binomial. But we can recognize it because the first term has to be a perfect square. The last term has to be a perfect square. And that middle term is always a product of 2 times the square root of the first and the square root of the second. There is a formula for that as well, and so we'll write that formula. So if we have a perfect square trinomial, which is a plus b squared, we can square the first term, multiply the product of both terms by 2, and square the last term. So both of these are going to the product is a perfect square trinomial. One is a sum squared and one is a difference squared. Same thing here. I'm not going to go through all that because I am trying to shorten my notes down a little bit today. So this is also a perfect square trinomial, but it's an a minus b squared, right? So we're a and b. So in, for example, in number 2, x is a and 5 is b. That makes sense, Grant? Okay. So it's a minus b squared. It's a squared minus 2ab plus b squared. So this would be x squared minus 5x minus 5x plus 25 if we use FOIL, right? And it would equal x squared minus 10x plus 25. Noting that when you're looking for a perfect square trinomial, when you're factoring over the next couple of days, this last term is always positive. You guys use the formula or the shortcut to square number 8. Already did it, Caleb? Number 8? You got it, Angel? So a is x and b is 3 if you're using the formula. Remember, once you're done, if you put your pencil down, I know you're done, and I'm not waiting on you. All right, if we use the formula, we square a, that's our x now. We multiply 2 times a and b. I'm going to put them in that order. And b squared, which is 3. So it's x squared plus 6x plus 9. You do not have to show me that step. I do expect you to be able to see that in your head. You can if you want. All right, so we're going to use the formulas here. Noting that the terms of a coefficient on some of them. So we're going to do 1 and 3. All right, so let's go ahead and do number 1. So if it helps, identify what your A and B are. If you're using the formula, no, you don't have to put a sign on your A and B. This is a different squared, so we know it's going to be A squared minus 2AB plus B squared. So then the signs are already taken care of in the formula. All right? So if we square 2x, 4x squared, minus 2 times A times B, so 2 times 2x times 1, so 4x, and square B. If you forget the formula, forget the shortcut, you can rewrite it to binomials and use distributive property or use FOIL. You guys see number 3? Any questions on number 1? Hudson, stick your head up. Are you all done? Okay, so look at me. I think I've said this a bunch of times. I don't want you to do that. I don't want you to work ahead, okay? I'm happy you're confident. But I still want you to follow along with this. I might have a suggestion, or you might remember something wrong on occasion, right? And you haven't seen a lot of this in a while, right? So please follow along with me. I don't mind if you work ahead a teeny bit, but don't get all the way through your notes and put your head down, okay, buddy? All right. Remember, once you're done, put your pencil down, and I'll know you're done. So for number 3, A is 4x, and B is 3. Notice there's a 3 and a negative 3. We're not looking at the sign. What did you get for the product, Leo?
For the product of just the answer? 16x squared minus 9.
Perfect. 4x squared is 16x squared. 3 squared is 9. So a difference of squares, identical binomials, one's addition, one's subtraction. Square the first term, subtract, square the second term. Okay. Cubing binomial. I know you've done a lot with squares, and I know that you've done a fair amount with cubes probably. We're going to multiply the cube square or binomial cubes long way or kind of long way, and then I'm going to give you the formula for that. Remind you what the formula is for cubing a binomial. For number 1, if we're doing it without the formula, we're going to remember that it's the binomial cubed. And when we write it that way, we should recognize, oh wait, that's also a binomial squared. And we just reviewed the formula for that, right? So the shortcut for that. So I'm going to bring down the first binomial, and then I'm going to use my formula. So that's going to be times x squared plus 4x plus 4, because I'm remembering my formula or my shortcut. Now we're going to distribute, and we only have 2 terms to distribute, right? So we're going to distribute the x to everything. And then I'm going to distribute the 2 to everything. I'm not sure that the formula is easier than this. I think I almost feel like this is the easiest way to do it, but I do want to remind you of the formula. I do want you to have that option. I do want you to have seen it again before you see it in college. So that's why we're reviewing it. All right, I'm marking my log term. Everybody agree with my multiplication here? X cubed plus 4x squared plus 4x, 2x squared plus 8x plus 8. All right, so we're going to write it in standard form. X cubed the biggest degree. I've got x squared. I've got x's. Alright, and I'm marking them off to make sure I included everything in my answer. Not super neat. Oh, I added an imaginary 4 there. There's no other concept. So it should be +8, right? Questions? Alright. I'm not going to take the time to prove this. We don't have time to prove it. I'm just going to give you this formula for cubing. So if we're cubing a binomial that's a sum, so we're going to write that as a plus b cubed. The formula is cube the first term is plus 3a squared b plus 3ab squared plus b to the third power. So if you're cubing a sum, all the signs are addition. The first and last terms are always cubed. We can make some comparisons to the squaring of binomial, but I don't know if that would clarify or confuse, so I'm going to try to do less for both. All right, if we're squaring a difference, it is just a little bit different. First and last term are going to be the same, but now we're going to subtract 3a squared b plus 3ab squared and minus b cubed. So the difference is, if it's addition, all addition. If it's a difference cube, plus minus plus minus. All right, we're alternating that. That's the way I remember it. So we're only going to do one of these. We have the formulas for them. The trick is, once again, ignore the signs when you're assigning A and B, right? So for number 1, I'll split it to number 2. We're going to say A is equal to 2x, and B is equal to 5. The signs are taken care of in there. Does that make sense? With me, Ashton? Okay, so we're going to plug into this formula. So it's 2x cubed minus 3 times 2x squared times b, which is 5, plus 3 times 2x times 5 squared plus, minus 5 cubed. If you don't remember this formula on an assessment or something, you can use the other strategy, right? I don't know which one you feel is easier, but I would like for you to try to practice this strategy on your homework stuff, all right? So we're going to cube 2x, and that's going to be 8x cubed. This is 4x squared times 3 is 12 times 5 is 60. So 60x squared. 6 times, this is 25 times 3 is 75 times 2 is 150. Y'all check me. And 5 cubed is 125. Is my math mapping? You hope so? Gonna be somebody else besides Greg to check this one, he says, right? Zachary, does that look right? You get the same thing? We could have taken more steps. You can take more steps. Simplify it more. I did a lot of simplifying in my head just for the sake of time. And let's go ahead and practice. Anybody have questions on that? So we didn't do a sum cube. The sum cube's a little bit easier probably just because it's all addition, right? And lastly, we're going to practice squaring a binomial that has 2 different variables in it. So different variables in first and second term. But the thing is, it's just the same, right? It's still going to be the first term squared minus 2 times the product of the term plus the last term squared. So the first term squared, 2x. I'm going to put in a few more steps. Minus 2 times 2x times 3y plus 3y squared. So that's the shortcut, right? Does that make sense, Ava? Sure. I saw your brow furrow. All right. So remember the formula. helpful if you identify your A and B. Remember, ignore the sign when you're doing that. So then my A squared is 2x squared. It's always minus 2, but then it's times whatever A and B are, 2x and 3x. And the last term, the B squared. So it simplifies to 4x squared. Why can't I math? 12xy plus 9y squared. Any questions? Do I need to go back to any of the problems? Grant, you didn't like number 11? You hate it? You loathed it. Nice. Way more descriptive. What part didn't you like about it? It's a lot. Hey, favorite, least favorite phrase for me to hear. Consumers. That's too much. It's a lot, though. I get it. But remember, I want you to practice that formula that you can do it like number 10. Did you like number 10 better, Grant?
Yeah.
You like that strategy better where you square the binomial? Yeah. And I do want you to work some problems both ways then, right? If you're good at this, let's concentrate more on the other way for homework. Definitely practice this strategy though, right? Because that's your backup, right? So we want to practice the things that are harder for us. That's the whole point of this course, right? So when you see them later in college, that you feel more comfortable with them. All right, I think that's all. Remember where to find your assignment. It's on the home page in Canvas. It's also in the module.